Okay, so you guys were asked to look at these examples, and my hope is that you guys got, in each of these examples, in number 5, you guys got the degree of the numerator to be 2, the degree of the denominator to be 1. Because the degree of the numerator is bigger than denominator, this has no horizontal asymptote. If I look at number 6, the degree of the numerator was 1, the degree of the denominator was 3, so because the degree of the denominator is bigger than the degree of the numerator, we can say that the horizontal asymptote is going to be at y equals 0. Looking at this last one, number 7, the degree of the numerator is 2, the degree of the denominator is 2. So it looks like I have to look at the leading coefficients. So the leading coefficient of the numerator is 3, the leading coefficient is 1 in the denominator, so we're going to divide those two numbers, and you guys get y to equal 3. So, what happens when I run into a situation like number 5, in which I don't have a horizontal asymptote? What do? Well, I know that we're going to be looking at an idea called oblique asymptotes. So, if a rational function does not have a horizontal asymptote, then the rational function will have something called an oblique asymptote. And how are we going to find those? We're going to use something called polynomial long division or synthetic division. That's what we were talking about in the last unit. So let's look at a couple examples, and then I'm going to have you guys try a couple just to kind of work it out. So looking at this situation, I have x squared divided by, or x squared minus x minus 14 divided by x plus 4. I know the degree of the numerator is 2. I know that the degree of the denominator is 1. Therefore, it has no horizontal asymptote. So, what I have to find is what the oblique asymptote is. So in this case, because I have a binomial, I can use synthetic division to help me find out where that horizontal asymptote is. So I'm going to say negative 4 is going to be substituted, or using synthetic division, into x squared minus x minus 14. So I have a 1, I got a negative 1, and I got a negative 14. So I'm going to plug 1 in. I'm going to bring down the 1. 1 times negative 4 is negative 4. Negative 1 plus negative 4 is negative 5. If I take negative 4 times negative 5, I get positive 20. I do get a remainder of 6 in this case, but my oblique asymptote is going to be located at y equals x minus 5. And that is a graph that is going to act like a horizontal asymptote in which parts of my rational function are going to approach but do not cross. So let's look at another example. Let's look at number 2. In this case, I have x cubed plus 3x squared divided by x squared plus 2x minus 3. In this case, I do have the degree of my numerator is 3, and the degree of my denominator is 2. So there is no horizontal asymptote in this case. So what we're going to do with this is we're going to do some long division, because I can't use any synthetic division to kind of get this going, or to find out where that oblique asymptote is. So I'm going to look at x squared plus 2x minus 3, and that's going to go into x cubed plus 3x squared. So, first thing I'm going to do is take x cubed and divide it by x squared. I know that's x. So I'm going to take x times x squared plus 2x minus 3. I do get x cubed plus 2x squared minus 3x. And I'm subtracting those quantities. So if I take x cubed minus x cubed, that is 0. 3x squared minus 2x squared is x squared minus 3x. So I'm going to take x squared divided by x squared, and that is going to be 1. So I get x plus 1. I'm going to take 1 times x squared plus 2x minus 3. I get x squared plus 2x minus 3. And I'm subtracting these. So in this case, I'm taking negative x squared minus x squared is 0. I get negative 3x minus 2x, which turns out to be negative 5x plus 3. But it doesn't matter because this is your remainder, 5x, negative 5x plus 3. Your oblique asymptote is going to be y equals x plus 1. So over the next few minutes, I'm going to ask you guys just to take a look, take a gander at these two. And in the next video, we'll kind of go over what you should have gotten the oblique asymptotes to be. Thanks.